Hey everyone, my name is Richard De Beer and I'm the lecturer for the course DSC 2604. I'd like to talk now a little bit about the time value of money and the related concepts of net present value, internal rate of return, and how we can use Excel to calculate what we need to about these things. So we'll start by taking the time value of money into account. Inflation, for example, interest rates. What does it mean, and how do we compute these quantities? So the basic idea is that money does not retain its value over time, it changes its value. Typically it decreases in value. 1,000 Rand 10 years ago can buy much more than 1,000 Rand in this year. When you deal with projects which have income streams that range over a long time scale of several years, we need techniques to compare the projects and thus determine which one is the optimal project. Here we use net present value and internal rate of return. So let's start with recapping what inflation means. Suppose it's said that the inflation rate is 10% per year, then what it would mean is that 1 Rand today, something that costs 1 Rand today will cost 1 Rand 10 next year. Likewise, X Rand today, the same thing would cost 1.1x next year. So we can do exactly the same calculation. Instead of 10%, R%. So we get these formulas that I think you know well. So what happens if we are interested in the value of X Rand 2 years from now, not 1? Well, there's the formula. You see you get a squared over there. This is because the first one of these terms applies to convert X Rand from this year to the amount 1 year from now. Then you apply that same term to move it 2 years into the future. And more generally, in n years time, you get this. Now, what about going backwards in time? Well, it's exactly the same formula, really. Suppose you have something that costs X Rand today, and you want to know how much it cost last year. Well, let's call that amount Y Rand for now, until we figure it out. Now, from the calculations we've just looked at, Y times this must equal X. So if I take this term over, I get that. What about N years ago? Well, exactly the same calculations. Y Rand N years ago times this quantity, as we've seen, will give us the value of the money n years into the future, which is today. That's X. So taking this term over, you get Y equals that. So to summarize, this formula works for n being positive or negative, that is, in the future or the past. Now, turning to Excel, if we wish to actually compute such terms as these, we use the power function. So that is what you would type in, where R, N, and X are the variables corresponding to these three quantities: the interest rate, the number of years, and the original amount. Now, turning to the net present value, what does that mean? Well, it takes all the amounts in an array. So you have a whole income stream, for example, and you have the interest rate, which is a number between 0 and 1. It is given as a number between 0 and 1. So if it is said that the interest rate is 5%, you must use 0.05, for example. The idea is that we wish to get the cumulative value of this array of prices or amounts on a time period, the same time period. That's why it's the net present value. So this, what is being described here, is how the Excel function NPV actually works. I will do an example just now. So here is something for you to read, and you can practice it in Excel at your leisure. If you have 10 amounts and the interest rate is 8%, then this formula would give you the net present value of all those 10 amounts combined, all in the same year, which in fact would be the year just before that of the amount in A1. Now, a separate idea is that of the internal rate of return. This number is an interest rate. What interest rate is that? Well, it answers this question. If I invested money in a bank account instead of investing it in the project, now I'd like to compare the two outcomes. Which is better, simply investing it in the bank account or investing it in the project? Well, this question is, what interest rate would the bank have to offer me to give the same return as what I would get if I invested in the project? So you can compare then the internal rate of return to the prevailing interest rate and see whether or not you should rather invest in the project or simply in a bank account. If the internal rate of return is greater than the interest rate, then it makes sense to invest in the project, because that effectively gives you a better rate of interest, better return on your capital. So now let's look at an Excel example. So I've made this example here. This is a project I just made up, expenses, income. So this is the net income. What I've written here is the present value. This is now in the year 2015, how much do each of these values come to in the money, in 2015 money. So there you see I've used that power formula. C1 is the interest rate. Now note that I didn't have to divide by 100 like we discussed, because this cell is in percentage. You see there, percentage. Others, like this cell, are general. The cell that's in percentage, you must read every number in that cell as already divided by 100. So that number sitting here is actually 0.05. That is why we did not need to divide by 100 over here. Here, 2015 minus A5. A5 is this cell here, so that this quantity actually is minus 1. So that's 1 year earlier. So this is correct. This 5,000 Rand in 2016 is the same as 4,761 Rand in 2015. Now, if you go to formulas, you can click trace precedence. You can see exactly which cells were used to compute the value of this given cell, which is often handy for figuring out what's going on in a spreadsheet. Here I can just remove the arrows. Another thing you can do, show formulas. Now you can see not the values of the formulas, but the formulas themselves to tell if they are correct or not. Now, another simple thing to do, if you go to the bottom right hand corner of the cell, I will drag it down. Okay, this has made bad values, but you will see exactly what has happened. Let's go to this one, trace precedence, and compare it to the original. So you see, when you drag down a cell, Excel simply drags down all the precedents along with it. But this is not quite correct. What we actually need here still is C1. C2 is blank. So to ensure that it is correct, I can go back to this original column here and put a $sign in front of the 1. Now, that $sign tells Excel it must not change the value of C1. That must be a constant. So let's drag it down again. There. Now it's given the correct values. So let's work out the net present value. This column of numbers corresponds to the present value of all these values in column D. Let's add them up together. There, plus, of course, the original amount D4 that had to be invested. So we get 2,704 Rand is the net present value of this entire stream of incomes over in the amounts of 2015 rands. So in today's money, so to speak, or next year's, I could have used the NPV function instead. Equals NPV. The rate is C1. The values that I'm going to try to find their net present value of are those. Now, what is this amount? This amount, as I explained earlier, is the net present value of all of these amounts from D5 to D10, or better still, I can just trace precedence, you see, all those amounts in the year before the first one. So that is exactly in the year 2015. To this, I just add the amount we had to spend in 2015 to get the project started. And you see they do give the same answers. This one has too many decimal places. And I can change it by going to Home, here, Decrease Decimals. I'll have to again. For the internal rate of return, I write equals IRR. The values that I want are all of them. And as for the guess, we won't discuss that further, just put in 1. It should always work in these cases. And you get 6%. Maybe just to increase the number of decimal places. You can definitely see it's better than the interest rate. So it would be better to rather invest this money in this project than in a bank account offering 5% interest per annum. Right, in our next video I will show you how we can analyze what happens if you use different interest rates. How will it affect the net present value and internal rate of return? Okay, thank you very much.